Okay, chapter 6.6, the unit circle, page 2, and here it is, the unit circle. So as you look at this, I want to point out that these values probably look fairly familiar. Okay, we have got the special right triangle angles that we were looking at. So if I take a look at this first point right here and I drop my altitude, see if we can get that just a little bit more pronounced. Yeah. Here is my 30, 60, 90 triangle that we used as part of our special right triangles, that we saw as one of our special right triangles. Again, this is a unit circle, so my radius is 1. Length of the short side is 1/2. Length of the long side is square root of 3 over 2. And so when we look at this ordered pair, that's the ordered pair we get, square root of 3 over 2, 1/2. Okay. Our 45-degree angle is next. Notice that the coordinates there are square root of 2 over square root of 2, comma square root of, square root of 2 over 2, comma square root of 2 over 2. And then we have our 60-degree, our pi over 3, where our coordinates are 1/2 square root of 3 over 2. Okay. Now, there are patterns here. If you take a look at the pi over 6 family of angles, you will notice that the magnitude of the coordinates are the same. So the x is the same, the y is the same, the size. The only thing that's different is the sign, and that sign is based on which quadrant we're in. Okay? So if you take a look at quadrant 2, you'll notice I still have root 3 over 2, 1/2, but because I'm in quadrant 2, my x coordinate is negative. I get a negative square root of 3 over 2, positive 1/2. In quadrant 3, where both x and y need to be negative, we got negative square root of 3 over 2, negative 1/2. And in quadrant 4, where x is positive but y is negative, positive root 3 over 2, comma negative 1/2. Now, there is one thing I want to point out that we don't always see. No, not that. I am going to write 1 just a little bit differently. 1 I can rewrite as 2 over 2, which means I can also write it as square root of 4 over 2. Am I ever going to write it this way? No. But everything here is a pattern. So I got square root of 4 over 2. If I'm looking at my x's, square root of 3 over 2 is next. Square root of 2 over 2. And then just to be consistent, I can write 1 as square root of 1 over 2. And square root of 0 over 2. Okay. Notice with our x's, we start with the 1, square root of 4 over 2, and then we just go down. Square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, square root of 0 over 2. The y's are reversed. I start at 0, square root of 0 over 2. I go up, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. Okay. So there is a pattern. If I'm taking a look at my 45-degree angles, my pi over 4 family, there's my 1 pi over 4 in the first quadrant. Here's my 3 pi over 4 in the second quadrant. Here's my 5 pi over 4 in the third quadrant. Again, all of these reference angles are being made with the x-axis. And then in the fourth quadrant, my 7 pi over 4. Okay? And again, we can compare those coordinates. Because of the symmetries of the circle, everything looks the same on the left and the right. Everything looks the same going up, going down. Okay? So just as a reminder how we got these values, when we talked about a 30-degree angle, and I'll be honest, I remember this by remembering that a 30-degree angle has got my triangle lying on its side. Okay? So short side is opposite the 30-degree angle. I remember that with this triangle lying on its side, the long side is square root of 3 over 2. That's my x, that's my cosine. For our second triangle, sorry, let's add in that coordinate point like I did in the last set of notes. I got square root of 3 over 2, 1/2. For our 45, 45, 90, yeah, it doesn't look so 45, 45, 90. Yeah, a little better. This is my 45-degree angle. Also pi over 4. I'll fix the one to the left in just a minute. With a radius of 1. We have an opposite side of square root of 2 over 2, an adjacent side of square root of 2 over 2. So this point at the end of that 1 unit hypotenuse is square root of 2 over 2, square root of 2 over 2. Our last special right triangle that we're using has got a reference angle of pi over 3, or that's 60 degrees. Which now means now my cosine is the short side. My sine is that long side. I get a coordinate pair here of 1/2 square root of 3 over 2. Let's see if we can find these. Here is my pi over 3 family. And again, it's the reference angles that we're talking about. So the angles that are made with the x-axis. Notice all of my triangles come off that x-axis. Nothing gets made with the y-axis. And then we have our quadrantal angles and those values.